Hey guys, welcome back to another Algebra 2 video. In this one, we are going to be talking about exponential and logarithmic equations. What I mean by that are equations that have either your variable up in the exponent, like that, or where your variable is kind of trapped inside a logarithm, whether it's a regular logarithm or like a natural logarithm, something like that. But before we can jump into how to solve these things, we need to talk about the tools we already have and the tools we don't have, and why we need uh, something new to solve these. Now, the way I solve these might be a little bit different than what you've seen before. It's kind of I don't want to say unique approach, but it's not quite as often that I've seen this method as some others. But I find this to be the most intuitive and the easiest mechanically as well. Okay, so let's just start by thinking about what a normal equation looks like. So if I know this is a very simple equation. If I have something with multiplication in it, and you can guess what that is. We know this is 5. But if we didn't know that was 5, we needed a tool. We needed a tool to get x by itself, right? So the tool we use is the opposite of multiplication, which is division, and we know what that is. Okay. Same thing with addition, right? To solve this equation, we need the opposite of this uh, operation in order to solve this equation, right? So in order to get x by itself and to solve these equations, we have to have something that cancels out anything around it. So what we're going to have to do is find a way to cancel out some logarithms. To do that, let's think about what happens if we have a logarithm base 2 of, say, 2. Now, if you've seen my log video, or if you know anything about logs, you'll know that this is just the question 2 to what power gives me 2? And hopefully the answer to that is pretty obvious. We just want the 2 to be left alone. We don't want to be to any other power. So the number that goes up here is 1. So the answer to this is 1, right? But it doesn't have to be 1. What if, well, this one has to be 1, but what if we put something else up here, like say a 5? Then this question becomes 2 to what power is 2 to the 5th power? It's kind of a strange thing to ask. Like 2 to what power gives me a power of 5 on 2? In other words, what do I have to put here for these to be the same? 5, right? And this works for any logarithm. Let me do another couple just to drive the point home. So log, oh, where's my pen? Log base, I don't know, 6 of 6 to the uh, smiley face. Okay, well, just to show you that it works with anything. This is like saying 6 to what power is 6 with a smiley face on it? Obviously, what goes here is a smiley face. So that's the answer. But what you can think about, you can kind of notice that whatever is up here ends up being by itself down here, which means when I put this log on this base of 6, these things just cancel out, and all I'm left with is that exponent. And that's the tool we need. We need to be able to cancel out that base. All right? So we can use that to our advantage. So let me go to our first example of an actual log equation. 2 to the 3x minus 1 equals, let's say, 32. Okay, conventional methods will not work to solve this. We can't just divide something away. A lot of students might be tempted to, see that 2 and you can divide both sides, but dividing only works because it's the opposite of multiplying. But we're not multiplying here. We're raising to the power of this stuff up here. So we need to get rid of a base of 2. So what we do is we take advantage of the fact that a log base 2 will cancel that out. And if I do something to one side of the equation, I've got to do it to the other side, just like that. Now, this is beautiful because what that does for me is on the left, all of this stuff is gone. Right? All that's gone. So we're going to cancel all this out. Gone. And what's left is just what's up in the exponent. So this is what's remaining. So I'm just going to bring it down. 3x minus 1 equals. And now on my right side, that's just a simple log. And so we're going to think about what that log is. This is saying 2 to what exponent gives me 32? Think about it for a second. You'll remember that 2 to the 5th power is 32. So this over here is just 5. And now this once very scary exponential equation has turned into a very simple Algebra 1 style two-step problem. So we're going to add 1 to both sides. That goes away. I have 3x equals 6. And now to get rid of the 3, you just divide both sides by 3. And x is 2. And that's it. So the idea is you want to try to match the base with the log, take it on both sides, things cancel out, and if it's nice, then you'll get a whole number. Sometimes you don't get one. The problems I'm going to show you today should work out nicely. I'm going to construct them in a way that you'll get whole numbers for the most part. If you don't get that, you can always plug it in the calculator, and it'll give you some decimal, and you can carry on with your calculations. Okay, let's do another one. Let's say I have a base of 5, and I have 3x plus 4 equals, let's go with 125. Okay. So, if you want to go ahead and give this one a shot, you can pause the video and try it yourself. And if not, you can continue watching. What we're going to do is the same thing we did last time, which is to match our base. And remember that a log base 5 will cancel out this base of 5 on the left. And if I do it on the left, I have to do it on the right. So there's that. And now all of this goes away, and I'm left with whatever was in the exponent. And it is now no longer an exponent. It is just normal-sized numbers and letters. And now on the right, I'm going to look at this and say, I can calculate that. This is saying 5 to the power of what gives me 125. And that exponent is 3. So this is a 3. Okay? And then you can carry on and solve like you normally would. So subtract 4 from both sides, you get negative 1. And then x is going to give me x is negative 1. Okay? So again, these equations are very simple after the first or second step, because they're just Algebra 1 equations. The trick is to remember that you have to use a log, 1, and then 2, you have to know what a logarithm is on the right side to compute that. And if you don't, again, you can use a calculator for that part, if that's something that you're allowed to do. Okay, let's do another one. Let's go with, we'll use a 2 again. 2 is easy to work with. Let's do 5x minus 3 equals, let's go with 8. Okay, give this one a shot on your own and see how you do. Okay, so I'm assuming you've tried it, and obviously, again, as you're doing these, try to do all of them that you can on your own. So make sure you're pausing the video, trying them yourself, and then come back to me. Okay, we're going to go log base 2 on both sides. That cancels this out. I'm left with 5x minus 3 equals, log base 2 of 8 is 2 to the what power is 8? That is 3. Add 3 to both sides, I get 6, so x is 6 over 5. I'm just going to divide both sides by 5, and I just like to leave the number as it is. It's an improper fraction, but that's okay. So it's 6/5. And it's really that simple. And as long as your base is a basic number over there, you can just put that base down there, and uh, and these just become basic equations. Well, what if you have, instead of a number base, you have, well, technically still a number, you have something like this. These show up quite a bit. Let's do something like this one. Let's say that. Okay, so now I have an exponential equation, but instead of the base being a whole number, it is a letter. Well, we know that e is actually a number, right? It's approximately 2.71828 and all that stuff. It's the exponential number. It's Euler's number, right? But none of that is important right now. You don't have to know what e is. You don't have to know where it comes from or why it's used or anything about it. All you need to know is that if I want to cancel out a base of e, I need a log base e, right? But instead of writing log base e, we're going to remember that there is a symbol for that, and that is natural log. So instead of using log base e, I'm going to say natural log on this side and natural log on this side. Now, other than the difference in symbol and the notation, this is functionally, mechanically, the exact same as what we just did. Because what happens is, get different color, this stuff goes away, cancels out, and you're left with whatever the exponent was. And now, hopefully these are easy to compute. They won't always be, but this one I made to where it's pretty simple. This is saying, remember the base is e here, right? So e to the power of what is 1? In other words, what exponent would you put on e to make 1? Well, that's the same exponent you put on any number to make it 1. E to the 0 power is 1. Anything to the 0 power is 1, right? So what is that exponent? It's 0, right? And now I can just solve this like I normally would. I'm going to add 1 to both sides and divide both sides by 3, and I get 1/3. So this technique works just as well with exponential functions with the exponential number. We should probably do another one like that. Let's do one where it doesn't work out quite so nicely. It's not bad, it's just one where the logarithm isn't obvious. All right, let's do this one. Equals, say, 5. Okay, now I encourage you to pause the video, try this one yourself, and go until you can't any further, and see if you can figure out what to do here. Okay, so if you try this, you'll notice there's something a little tricky about this. Slightly. It's not bad, but... so I'm going to do the same thing I did last time. I'm going to do natural log on both sides. What happens is this goes away. This comes down. 2x minus 4. Now, normally, what I'm able to do is this thing right here, I'm able to calculate it and turn it into a number, right? But I don't know what the natural log of 5 is. I just don't. That's not something I know. So you can, one, put it in a calculator and it'll give you some decimal, some gross decimal. Or in my classes, to promote an symbolic manipulation and to get kids to, be more used to manipulating symbols, I want you to just leave this the same. So you could punch this in a calculator, or you could just literally leave it. And now you just work around it. So I'm just going to leave this. Remember, this is, not to put too much of a emphasis on it, but this is important. This is just a number. If you were to plug it in a calculator, it'll give you a number. I don't want to find out what it is. It's just some decimal. But you can work around it. So now I can just carry on like I normally would. I'm going to add 4 to both sides. But now I just add 4, just like that. And now I'm going to divide both sides by 2. So I divide all of that by 2. And so now x is this number. Okay? And if you are wanting to leave it like this in an exact form, you can. Or if you need a more approximate number, like an actual number, you punch this in a calculator and it'll give you a decimal. Okay? All right, let's do another one like that. Let's go E. You try this one on your own. E, 3x minus 1 equals 2. All right, pause the video, try that, and then come back and see how you did. Okay, so natural log, both sides. Cancels. 3x minus 1 equals natural log of 2. I have no idea, so I'm going to leave it alone. I'm going to add 1 to both sides, and I get natural log 2 plus 1. Divide both sides by 3, and I get all of this stuff over here, all divided by 3. And that's my answer. Now, I'm sorry if I went through that kind of fast. I just realized I just kind of flew through that. But again, I'm assuming that you have paused it and you have done it yourself, and then you can watch me solve it and check to see how you did. Okay, what if there's some other stuff going on besides just an E or just a base of 3? What if you've got some other things happening? For instance, what about this? We'll stick with the E business for now. Because we've been working with them. How about this? Now notice that I can't just take the natural log on both sides. I mean, I could. There are ways of dealing with that, but it's not going to be so straightforward, and we're not going to want to get into all that. So it's always best, if you're going to try to get rid of this thing, to have it isolated. So how are we going to get rid of that 5? Well, even though this is kind of a complicated looking equation, the 5 part is not. It is just 5 times something. It doesn't matter what this is. It's still just 5 times a thing. And how do you get rid of 5 if it's times a thing? You just divide by 5. Let's not make that too complicated. So you can do that. It's not a problem. And now I have e, the x minus 4 equals, and now this becomes 4. So what looked like a horrible equation with a thing out front, now it just looks like, well, maybe it still looks like a horrible equation, but at least it's more like what we just did. And now let's carry on. We've got natural log on both sides. Those are gone. X minus 4 equals natural log 4. I don't know what that is, and I don't care. I'm just going to add that other 4 to both sides. There we go. And we're done. Okay. I guess for completeness, we could do another one kind of like that with... well, you know what? That's probably enough of that. Let's go the other way around, because the other half of this video was logarithmic equations. All right, so logarithmic equations, that's things like if I've got log base 2 of 3x minus 1. So I've got an x that's trapped inside my logarithm, and that's equal to something like, say, 3. Okay. We need to figure out how to cancel out this log. Now, I can't divide by log. That doesn't make any sense, because this is not times, is it? This is not a multiplication here. This 3x minus 1 is inside the logarithm. You could think of it as inside. It's trapped. So I can't just divide something away. I have to get rid of the log in a different way. So, side note down here, just like a log base 2 gets rid of a base this way, it also works the other way around. So it turns out, this is kind of wild. If you've never seen this before, just hold on for a second. It's going to look weird. It turns out that if you make this entire side the exponent of 2, watch, here's 2, and then this entire thing is an exponent. If you've never seen this before, I know this looks bananas, because we're probably pretty new to exponents, and all of a sudden I just said you can write like a whole formula or an equation if there's an exponent. It's nuts. But you can do that. And now if I do it to one side, I can do it to the other side. I'm going to exponentiate both sides. So now I've made both sides of this equation the exponents of 2. Now, why did I pick 2? Just to be totally clear here, it's because this 2 right here. Now, I constructed this because now I know that logs and bases cancel each other out. So all of this is going to go away. This is all just like before where we did the log and it got rid of the base. Now this base is going to get rid of the log. It's going to go away. All that is gone. And what is left is what was inside the logarithm. Isn't that nice? It's a beautiful thing. So now on this side, that's just 2 to the power of 3. That's 2 times 2 times 2. That is 8. Now I'm going to add 1 to both sides. That gives me 3x equals 9. Divide both sides by 3, and I get 3. Trying to circle it, it's not quite working with my pad. Okay, there we go. X equals 3. Okay, so the concept is exactly the same as it was with the exponential functions, except that instead of taking the log, we're going to undo the log with the bases. Let's do another 2 or 3 or several. You probably need lots of practice with this. Okay, let's do log base 3 of 2x minus, let's do 7. I think that'll work out nice. Okay, and that's going to equal, we'll make it 2. All right. Now, if you're comfortable with what we just did, then I encourage you to pause the video and try this on your own. All right. So let's do the same thing we did before. I'm going to notice that my base here is 3. So I'm going to make both sides of this equation the exponents of a 3. Just like that. And now I'm going to cancel these out. These are going to be gone. And this is going to go down. This is all that's left. It's no longer an exponent. Well, it's no longer inside the log. It's no longer an exponent. It's just normal numbers and letters. And now this is going to become a 9. Right? Okay, basic two-step equation. Here we go. Add 7 to both sides. We get 16. Divide both sides by 2. I get 8. Piece of cake. All right. Let's do more of them. Let's do lots more. I love these things. What about this one? Log base 2. Let's go x minus 5 equals, that's a good one. All right, let's go with 0. All right, give that one a shot. Okay, I'm assuming you've tried it. Let's get in here and do this thing. So my base is 2, so I'm going to go 2 to the power of log base 2 of x minus 5 equals 2 to the power of 0. Now, a lot of people get confused when using logs and ones and zeros because there's some weird things that happen with ones, zeros, and that stuff with logs. While log of 0, just a little side note, log of 0 is undefined. This is true. This is not log of 0. Remember, we put that 2 under it. So that's not what we're talking about here. This is just 2 to the power of 0. 2 to the power of 0 is 1. That's simple. So this goes away. This comes down. I have x minus 5 equals 1 because that's what 2 to the power of 0 is. And now I add 5 to both sides and I get x equals 6. Beautifully simple. I love this method. It's very simple. It makes sense. It's elegant. You don't have to worry about changing bases or anything like that. Okay, let's do one with a natural log in it. Let's do natural log of 2x minus 1 equals, let's say, let's keep it with the same kind of thing as last time. That way you can kind of Remember that. Okay, so remember that the natural log is just a normal logarithm, but with a base of e. So if I were to put that in here, it's a little base of e, right? So that means that I really am wanting to make this the exponent of an e. And same thing on this side. Now, just like before, these cancel out. Oh, let me just swap my colors again. This cancels out. I'm left with 2x minus 1. And like the last one, e to the 0, just like any number to the 0. Anything to the power of 0. 1 to the power of 0, e to the power of 0. Chicken to the power of 0 is 1. It does not matter. That is a 1. So now I add 1 to both sides, and I get 2. Divide both sides by 2, and I get 1. So this works just as well when you have a natural log. Okay. Let's do another one, but let's do one where it doesn't end up working out so nicely. Let's do natural log. Actually, you know what? Let's go ahead and do one with something out the front. 2x. We'll try that. And equals, let's go with, let's say, 15. Okay. Now, if you remember to the last unit we did, or not the last unit, the first half of the video, you can't really do stuff with these logs and exponentials until you get rid of the other things that are in front of them. So right now, I have a 3 out front, and this 3 is being multiplied. So even though we're talking about logs and we're talking about exponents and all this weird stuff, this 3 has nothing to do with any of that. It is just a 3, so you can literally divide both sides by 3 and get rid of it. It's gone. So that makes our new simplified equation, natural log. Now you can use the parentheses. I'm going to take them out. You don't have to have them. Just a notation thing. But just know that both of those are inside the logarithm. They're still there. Okay, you probably see it either way. All right, so now I have a new equation where the 15 has now become a 5. Now, as before, I'm going to raise both sides to the power of e. Well, I'm going to make both sides the exponent on an e, I should say. Oh, that's a funny looking e. Let's try again. There's that. Okay. The natural log cancels with the e. Those are gone, and I'm left with 2x on the left. On the right, I'm left with e to the 5th power. Now, e is just a number again. It's just like 2 or 3 or 5. It's just a number. It's a gross number. It's a decimal. So we're just going to leave it alone. And I'm going to divide both sides by 2. Now, when I do that, I'm left with something divided by 2. So that's actually going to be my answer. I'm just going to leave it as e to the 5th power over 2. And if you need, for whatever application you're doing, if you need a decimal, if your teacher wants you to completely simplify this to into decimal, you can punch that in a calculator and type in e to the 5th power and divide it by 2, and it'll give you some decimal. But for me and my purposes in my classes, we're just going to leave it like this. Okay. All right. Let's do one more, similar to that. All right. Let's go with 5 and natural log 2x minus 6 equals. I don't know. How about we'll just continue. All right, this is the final problem of the video. Make sure you try this one on your own, see if you can do it. Okay, let's see how you did. Notice this is a 5 times all this mess. I need to get rid of that 5, so I'm going to divide both sides by 5. This goes away, and I'm left with 5 on the right. Oh, it's not 5 on the right. I'm sorry. 10 divided by 5 is 2. All right, it's been a long day. Natural log 2x minus 6 equals, this is a 2. And now I'm going to make both of those the exponents in my equation here, e2. What is e squared? I have no idea, and I do not care, because I'm just going to leave it alone. I'm just going to, I tried to change colors here. Let's do different colors. Let's use this one. So this is going to go away. I'm left with 2x minus 6 equals e squared. I'm going to go up here and work. Have a little bit more room. So I'm going to add 6 to both sides. So I have 2x equals e squared plus 6. You just write it out beside it. And now I'm going to divide both sides by 2. If I do that, I get x equals e squared plus 6 all over 2. And that's my final answer. Okay, so that's it for this video on exponential and logarithmic equations. These obviously could get more advanced. There's other things you can do with them. There are other ways to do them, but for basic ones, I find that this is both a very simple mechanically and conceptually elegant solution method for doing this. So hopefully you learned a lot. I hope that you got a lot from this video and that you are now comfortable with these things. And I'll see you in the next video.